Assalamualaikum and hi. In this video, I will introduce varieties of piping components that make up a process system. Piping is also known as transport equipment to transfer fluid such as liquids, emulsion, suspension of particles, or pulps. During plant design, after identifying all unit operation or equipment for process and utility, we need to identify what are needed to connect the various equipment. In this example, this illustration shows main equipment. Shows main equipment needed in producing fresh cow milk. Uh, okay. The equipment needed for producing cow milk. The equipment needed to producing cow milk in a bottle. In the bottle. Try to open my laser pointer. Now it's working. Okay, this packed in bottle. It packed in bottle. So the equipment showing here, holding tank, separator, tank, small tank for micronutrition ingredients. This unit is like something like dosing, okay, to dosing the ingredients for standardization of milk. Pasteurizer here, which is plate heat exchanger. There is a cooling system here, homogenizer, and this is a filler machine to fill the milk into the bottles. All right. Now let me think. Okay, let me think how to connect all this equipment so that it can work well. Right. So here we can list components needed to connect the unit operation accordingly. We need pipe, piping fitting. Okay, of course we need piping fittings to connect all the pipe, and then valve, and we need pumps. Okay, this is how the process flow looks after we connect all the unit operation. This illustration shows quite complete process flow, where it starts from receiving the raw milk here, where then it's stored into the holding tank, and then from this holding tank the milk will be pumped into another unit operation. All right, of course there is a pump here, but this illustration is simplified illustration. The pump is not showing in this illustration. All right, and in this piping system, there is one outlet here, where this outlet is to allow easy access to the operator so that they can collect sample of milk for testing, for lab testing. And the main flow of these piping systems from the holding tank will be transported into one to the next plant, where it will producing cheese, and this will be the milk transport into the separator, where this separator will separate the milk into cream and skim milks. And here the pipes direct the milk into there is another junction here, where wants to go to the another processing line to produce butter making, to produce butter, and then This one, it transport the cream, some amount of cream into the dosing unit. And then the skim works from separator as well, transport into dosing unit, where here the dosing will control to standardize the milk to meet the desired milk content, the milk product content that we want. And as well, this tank as well, the piping will pump out the micronutrition ingredient into the dosing piping system here. Right. And then next, the pipe transport the standardized milk into plate heat exchanger, okay, for heat treatment. And then after that, it will transport the milk. The pipe will transport the milk into homogenizer, and then transport into the unit filler unit operation here. All right, and uh, some amount of the milk will be transport into the next processing line to produce evaporated milk, condensed milk, or dried milk products. All right, and then this from the filler machine, the milk will be pumped out and then fill into bottle. All right. So this piping connection has met the objective of producing cow milk in bottle. All right, and this piping connection is also known as piping system. Actually, to complete a piping system, not only piping fittings, valve needed, but we also need flange. Okay, flange is under pipe fittings actually. Then bolts and gasket, which are also known as fasteners and sealing. And there are some piping special items such as steam threads, pipe support, and valve interlocking. Pipe in the processing pipe in the process plant is acting like the main artery that connects various process equipment and utility equipment. Pipe are least complex compared to other piping components, and the design of pipes for process plant installation are following to ASME B31 codes. And pipe is generally made from metal, for example, carbon steel, stainless steel, duplex, copper, or to a lesser degree, one of the more exotic metals like Monel or titanium. They are also pipe made from non-metallic materials such as plastic like PVC, glass reinforced epoxy, or glass reinforced plastic. The way pipe is identified is by pipe sizing terminology. NPS stand for nominal pipe size, which is a North American set of standard size in defining the diameter of the pipe, right? This is NPS, right? And nominal bore, the value is the same as NPS, and this is terminology for European designation, right? And then nominal diameter, the abbreviation is DN, is actually 25 times the NPS. This term is the international and European metric method to describe NPS. All right. Nominal pipe size and outside diameter are not always the same. Okay, are not always the equal. Is equal. For an NPS 1/8 to 12, the NPS and outside diameter values are different. You can see this and this one. All right. For NPS 14 and above, the NPS and outside diameter are equal. Okay. While wall thickness of pipe, while wall thickness of pipe is described by schedule, and this is non-dimensional number for wall thickness, and other terminologies is standard STD, extra strong XS, and double extra strong XXS. Here is the range of wall thickness. All right. Some of the schedule number is added with letter S. With letter S. Okay, some of the schedule number is added with letter S. Okay, with added is letter S. Okay, like this one 5S. We do have 5. Okay, 10, 10S. For this one 20, 30, 40, and then suddenly we have 40S. Okay, 60, 80, then we have 80S. We have 100, 120, 140, 160, then followed by STD for standard, XS for extra strong, and XS for double extra strong. All right. Okay. Why there we have a letter S here? Okay, letter S. Where are we? Where is my... Okay, sorry. The letter S here is for stainless steel. Okay, for stainless steel. Okay, this is because stainless steel pipe have less risk of failure due to non-corrosive property and can be used with thinner wall thickness. All right, I would like to show in the next slide. Okay, I have this standard table, standard chart were produced by NPEL. I would like to credit this website. Okay, you can visit this website for further details. All right. And at this example, we look at 40. Okay, schedule 40, the thickness for the 40. So for the smallest size of pipe, nominal diameter, here we have nominal diameter. Okay, 1/8, quarter, then 3/8, half, half inch, the unit is inch. Okay, let's look at the beginning. The schedule is the same for both 40 and 40S, but it start to differentiate somewhere around here. Where are we? Somewhere here. Okay, this one, at this. Okay, so it start at somewhere, 12. Okay, after 12, I think. Okay, above 10. So if you look at this point, where is my point? Pen. Okay, this one. The value is differs. 40 schedule and 40S schedules is differ. So this part 40S is a bit thinner compared to 40S. So 40 is bigger than 40S. So this is due to the properties of stainless steel. Same thing happened at 5S, 80 and 80S. So where the 80S schedule normal, it has a thinner thickness compared to the 80. Okay. For the lengths of pipe, they are referred to as single random lengths. Double random lengths, longer than double random cut lengths. For single random lengths, the pipe is usually 18 to 25 feet plain end or 18 to 22 feet threaded and coupled pipes. All right. For double random lengths, it's between 38 to 40 feet. Okay, the length. while for longer than double random, the length is more than 38 to 48 feet. Okay, cut lengths, pipes are made in fixed length within plus minus 1/8 inch. But not all pipes are exactly cut to length, as they are more expensive. If long piping system is needed, double random lengths or longer than double random length is preferred. Double random length that are longer than double random length, as it will result less weld joints. However, this also depends on the size of pipe, as smaller pipes are too flexible, too VP, with a long length. Uh, there are several types of pipe ends. The most commonly specified in SME B31.3 are plain ends, threaded ends, and beveled ends. For plain ends, PE, usually it's for smaller pipe size, alright, 2 inch and below. The pipe is simply square cut 90 degree. Okay, 90 degree. You can see here 90 degree cut. Alright, where it cutting by cutting 90 degree perpendicular to the outside diameter of the pipe. And then for this kind of ends, there is no standard because of its simple geometry, and it generally used in combination with slip-on flange. This is illustration of flange and socket, and socket well flange. Okay, socket well fitting flange. Okay, so this photo is taken from this website, Vermec, right? Uh, threaded end, it generally is used for small diameter. It generally used for small diameter piping system, 2 inch and below, and it has standard. For this, it has standard ASME B1.20.1, right? Due to its complex geometry, dimension, and tolerance. Coupling for the connection, you can use coupling, or also known as threaded flange or threaded fittings for couplings. So this is it has standard for this type of connection, where is under SME B16.11. Bevel ends, or it's also known as butt weld or weld end. Alright, this is suitable for all size of pipe, all pipe size. Alright, and the connection is welding. Alright, the pipe will be directly welded, for example like this, alright, to each other or to other pipe or to the fittings. Alright, and the ends are mostly be beveled. Okay, look at here, it's be beveled. This one, okay, is be beveled to angle 30 degree with a root face. This is a root face around here, a root face 1.6 millimeter. Okay, it has specific geometry, and this is specified under B16.25 ASME B1625. Okay, all right. So this is illustration of the end pipe with butt well. Okay, butt well, or we call it bevel ends. Okay, beveled ends. All right. Pipes are fabricated using several methods. Common methods are seamless, longitudinally welded, spirally welded. For seamless method, or other name for seamless method is extruded method. Seamless method. This is performed by passing a solid billet. Okay, by passing a solid billet like this, passing the solid billet with a mandrel through a metal bar, which is at high temperature. Seamless pipe is commonly available up to 24 inch, and seamless pipe has quality factor of 1.0. Okay. All right. So this can refer in SME table B31.3, table A1. Okay. While for longitudinal welding method, the pipe is fabricated for size. The pipe is fabricated by feeding hot steel pipe. Okay, by feeding hot steel pipe. All right, let's say like this one. Okay, this is, let's say this is, oops, this is the camera. Okay, this is stainless steel plate. Okay, the pipe is fabricated by feeding hot steel plate through shapers that roll. It will roll the plates. Okay, it will roll the plates uh, into a hollow circular section. Okay, and then the two edge at this one. Okay, this cut is very hard, so it's very difficult to create a round shape. Okay, then this end. Okay, this end, these two ends will be welded at this end. Okay, will be welded. Okay, at these two ends. Okay. Well, and then longitudinal welded pipe is commonly specified for pipe size above 16 inch, but smaller size also are available. Its quality factor is 0.85 in SME B3 1.3 table A1B. Okay, but if radiographically extracted, quality factor uh, is around 0.95. All right. For spirally welded, uh, this is the least common method and is formed by twisting strip of metal into spiral pattern. You can see this is actually from the strip of metal, and then it joined by welding. Okay, welding the strip of the stainless steel and create a shape of uh, what they call it, like a tubular shape, right? All right. Spirally welded pipe is the cheapest, and it is generally used only for piping system in non-toxic service at atmospheric or very low pressures, and for very large size of pipe. However, it has quality factor of 1. Quality factor, it has high quality factor. For food and pharmaceutical industry, seamless pipe. Okay, seamless pipe. Oh, sorry. Okay, these seamless are the best for food and pharmaceutical industry. Seamless method are preferred over the welded type because their smooth surface can be cleaned and sanitized effectively. So table 2.1 is from it's from process piping design book, process piping design handbook, and it's actually part of ASME. This is actually part of. All right, let me write somewhere around here. This is actually part from ASME B31.3 table A1B. All right. I only show some part from the table. Yeah, for example, this part list is for where is my pen? Okay, carbon steel. Okay, pipe, and there are description here. Okay, here is the description of the fabrication method, and here is the quality factor P. Okay, it referring to quality factor. Okay, it shows the quality factors. And this show a part of table where it start to show data for stainless steel material. Alright. So this table provide quality factor that is needed. Okay, quality factors that needed. Alright. To calculate the wall thickness of pressure containing pipe. Alright, class. This is the end for this topic. Thank you for watching and bye.